Alright, next up is 83, and this one was kind of a nasty one for me, so bear with me here. 83. Okay, so in this one it says, there is a ball with a mass m, which is moving horizontally on a frictionless surface, until it hits a block with mass 3m. It says 3m. It is suspended with a 50 centimeter cable. So I'm just going to go ahead and actually change that right now to 0.5 meters because I like that unit better. And then, so this was initially at rest, it says. And when it collides with it, and it says it's an elastic collision, I believe. Yeah, it collides elastically. And then it wants us to find the maximum angle that the block swings up to. So it wants us to find this angle of theta. So, the first thing we have to do here is we have to figure out the initial speed of this block here. So to do that, this is 83, let me write that up here. That's a terrible answer, who cares? Not me. So the way to do this, the first thing we do is you get the equation for a elastic collision, which is 2m1 over m1 plus m2 times the initial velocity 1 plus m2 minus m1 over mass 1 plus mass 2, and that is multiplied by the initial velocity of your second one. So this second thing, so this is the first one. This is A1, this is 2, just to be clear here. So the initial velocity of 2 here is going to be 0, which means that all of this is just going to kind of go away. And then we can come back here and plug things in. So the initial velocity here was 4. I don't know that I said that, but it is. Let me just double check that. Yeah, it's 4 meters per second. Okay. And then mass 1 is m, so 2 times m. You use capital M to separate them. Then mass 1 plus mass 2 is going to be 4m, because this is m plus 3m, so that's 4m's total. You can cancel out the m's. We don't have to worry about whatever unit they're in. And then you end up with 2 here, or 1/2 here. Right? Yeah. Times 4 equals 2, because half of 4 is 2. So 2 meters per second is our initial velocity here. So this is all equal to your after collision velocity of object 2, just to make sure we're on the same page. So this guy starts with a velocity of 2. We can go ahead and get rid of all this stuff because I'll just rewrite it anyway. So v of 2 is equal to 2 meters per second. And then once we have that, we can go ahead and use a second equation here, where velocity is equal to the square root of gravity, or 2 times gravity, times length, times cosine of theta 1 minus cosine of theta 2. And then this is an equation for velocity of a pendulum between 2 different points, or 2 different angles. So this is the starting angle, this is the final angle, this is just gravity, the length of the string that it's attached to, and then the 2 is a 2. And then that gives you the velocity that it gets from moving from one angle to the next. So, yeah. So we have the velocity that it starts with. So the velocity at this point is 2, and that's going to equal the square root of 2 times 9.81 times the length, which is 0.5. And then you'll notice here that the 2 and the 0.5 will just cancel out, because 2 times 0.5 is just 1, and anything multiplied by 1 is just whatever it was. So 9.81 times the cosine of our initial angle is 0, minus the cosine of, I'm just going to leave that as theta, which is our second angle. At this point you can actually like plug this into a graphing calculator and calculate it out. If you leave this as like a y here, and then also graph the equation y equals 2, and then just calculate where they intersect, that'll give you the answer. Or if you really want, you can go ahead and solve it the long way. So it would be 4 equals 9.81 times cosine of 0 minus cosine of theta. So 4 over 9.81 times, or divided, but then, no, minus 1, because cosine of 0 is going to equal 1, because the cosine starts at 1 then goes down, where sine starts at 0 and goes up. So cosine minus 1 is equal to the negative cosine of theta. So you can go ahead and reverse that. So 1 minus 4 over 9.81 equals cosine of theta. That's theta. And then you just take the cosine to the negative 1, or arc cosine, and then that will give you theta. So theta in the end ends up equaling, what is it, 53.7 degrees. There you go.